Hello all. So this video is going to cover the remaining rules of equivalence. Those will be rules 14 through 18. As of right now, your videos will kind of look like this, where you're just going to get an overhead shot of my hands working some problems, but I'm hoping to get a slightly better setup going forward that'll have a document cam and a second cam so that you'll also be able to see my face as we go through this. So I apologize for the awkward format, but I'm hoping to streamline this process over the next week or so. Okay, so this is basically going to pick up where we left off. We had a few rules of equivalence left over. So as you'll remember, rules of equivalence work a little bit differently from our first 8 rules of implication in that we can apply them to part of the line or the entire line, and they go in both directions. So basically we're being given logically equivalent pieces that we can swap out whenever we need to. So the first rule that we're going to look at is called contraposition. And we're going to abbreviate that as contra. Contraposition basically works with the conditional in the way that commutation works with our conjunction and our disjunction. So as you remember with commutation, if you have a conjunction, you can flip the conjunction around, exchanging the location of the two conjuncts. Likewise, if you have a disjunction, you can flip the disjuncts around. But remember, commutation only works on conjunctions and disjunctions. If we want to flip a conditional around, it's actually slightly more complicated. So contraposition says that if we have a conditional, alpha horseshoe beta, for example, we can swap the location of the consequent and the antecedent. We can trade their places, but we have to either add or subtract a negation to each piece. And so if we have alpha horseshoe beta, we can flip the order as long as we negate beta and we negate alpha. And remember, this is adding an extra negation to whatever is in the antecedent spot. So for example, if I had a sentence like this, not a horseshoe B, and I wanted to use contraposition on it, I would either have to add or subtract a negation to each piece. And I can't mix and match. I'm either adding to both or subtracting to both. So in order to flip this around, I have to treat not A as my alpha, flip it around so that each piece gets a negation. So using contraposition would get me negation B, because I've moved B to the left piece and added a negation, and negation A, because when I move negation A to the consequent spot, it picks up an extra negation. Okay. Let's go ahead and work a problem that uses this rule. So let's say I've got a problem that looks like this, and we'll just draw a little line so that we know where we're at. A horseshoe B, negation C, horseshoe negation B, C horseshoe D, and as my conclusion, negation D horseshoe negation A. Now, when I take a look at this problem, what I see is that my conclusion is a conditional, and it has both D and A as parts of the conditional. D in the antecedent spot, A in the consequent spot. So I look around at my premises until I find the corresponding constants. Well, I've got A on line 1, D on line 3. So I know what I need to do is bring A and D together on the same line. In addition, I've got all these connecting pieces. So I've got a connection between 1 and 2 through the atomic B. I've got a connection between 2 and 3 through the atomic C. Now, when I've got conditionals that I want to condense down, such as I have here, I've got 3 conditionals and I want to end up with 1 conditional, usually my rule is going to be to use hypothetical syllogism. So my goal here is to use hypothetical syllogism to bring A and D together. But of course, in hypothetical syllogism, you have to have a perfect match between antecedent and consequent. So what that means is if I want to use hypothetical syllogism on 1 and 2, then I have to have a shared piece between the antecedent and the consequent. So I'd either have to have the same piece in the consequent of 1 and the antecedent of 2, or in the antecedent of 1 and the consequent of 2. But as you'll notice, I don't actually have that. What I have is in line 1, B in my consequent spot, and in line 2, negation B in my consequent spot. So first of all, this won't work because those don't match exactly. I need to have the exact same piece. In addition, they're both in the consequent spot, and hypothetical syllogism says I need one of each. So in order to do hypothetical syllogism on 1 and 2, what I'm going to have to do is clean the pieces up so that I get a perfect match. Now, fortunately, I have contraposition, which now allows me to flip a conditional as long as I'm adding or subtracting a negation. There's 2 ways I could do this, of course. I could flip line 1 or I could flip line 2. Line 1 might actually get us there faster, but I'm going to start by flipping line 2 so that you can see contraposition going in both directions. So what I'll do is I'll use contraposition on line 2. That will flip the order, and I'm going to use the right to left version so that each side gives up a negation. So B moves to the antecedent and loses a negation. C moves to the consequent and also loses a negation. And I get that from 2 and our new rule, contraposition. Good. Now I'm in a situation where I can actually do hypothetical syllogism, because in line 1 I have B in the consequent spot. In line 4 I have it in the antecedent spot, and they match perfectly, which is exactly what we need for hypothetical syllogism. So by hypothetical syllogism on 1 and 4, I get a new conditional, A horseshoe C. And I get that from 1, 4, hypothetical syllogism. Excellent. Well, I'm a little bit closer to what I need. A is connected to C, C is connected to D. I've just got to bring those together. Now, fortunately for me, I'm already set up to do hypothetical syllogism. I've got C in the antecedent on line 3, C in the consequent on line 5, and all I need to do is do one more round of hypothetical syllogism using those matching pieces to bring A and D together on the same line as a new conditional. And I get this from 3 and 5, hypothetical syllogism. Now I'm really close to finishing out this problem. I've got A and D on the same line, they're conditional. The only problem is that they're in the wrong order and they're missing negations. Fortunately for me though, again, I've got contraposition, which says if I have a conditional, I can flip the two pieces as long as each one either gains or loses a negation. In line 6, they don't have negations, but I want them to each have negations. So I'm going to use the left to right version, flip the conditional around so that D becomes the antecedent, A becomes the consequent, and each piece picks up a negation. I get that from 6 and contraposition. And we're done. Yay! Good. So that's one of our new rules. We've got a few more, so let's go ahead and move through them. Our next rule is actually going to end up being a very useful rule, is it's going to allow us to go between a conditional and a disjunction. This rule is called implication. And we're going to go ahead and abbreviate that as IMPL, so impl. Implication says if you have a conditional, alpha horseshoe beta, this will be logically equivalent to a disjunction where the antecedent piece has a negation on it. So if I want to take a conditional and turn it into a disjunction, I can do that as long as I negate the antecedent. And of course, because if it's a rule of equivalence, that means it'll go in either direction. So if I've got a disjunction where the left disjunct is negated, I can go ahead and turn that into a conditional as long as I have a negation to drop. Okay, so let's go ahead and take a look at a problem that utilizes this rule. Okay, good. So here we've got a few options. We could probably play around with this and just do a straightforward hypothetical syllogism with some contraposition like we saw in the last problem, but we've got another option, and that option comes from the recognition that we've got two conditionals, their antecedents are shared on line 1, and their consequents are shared in the conclusion. And I know if I've got two conditionals and I've got the disjunction of the antecedents, I can get the disjunction of the consequence using the constructive dilemma rule. So I'm going to make a little note here that I'd like to use constructive dilemma. Unfortunately, though, in order to use constructive dilemma, I'm going to need the disjunction of these antecedents, and that's not what I actually have on line 1. However, I now know that any conditional can be turned into a disjunction simply by using the implication rule. So I'm going to start by turning line 1 into a disjunction. Now when I do that, I'm using the left to right version, which means my conditional will become a disjunction, and whatever's in the antecedent spot, in this case negation A, is going to pick up one extra negation. So when I use implication on line 1, what I end up with is negation, negation A, because my antecedent gains one extra negation, or B, because my consequent is transferred over exactly as it is. And I get this from 1, implication. Next, I'm going to have to clean this up before I can do constructive dilemma, because constructive dilemma requires the disjunction of my antecedents. Fortunately for that, all I need to do is double negation to knock out these two negations. That will leave me with A or B from 4, double negation. Good. Now I'm in a position where I can go ahead and do constructive dilemma. I've got two conditionals on 2 and 3, and on line 5, I have the antecedent of those two conditionals. When I do constructive dilemma on 2, 3, and 5, what I end up with, of course, is the disjunction of the consequence, which will give me D or C. And I get that from 2, 3, 5, and constructive dilemma. All right, we're getting pretty close. We've got D, C on the same line, but unfortunately, the conclusion calls for a conditional. All I have on line 6 is a disjunction, but I can work around that. I know that if I've got a disjunction, I can turn it into a conditional as long as the left disjunct has a negation to lose. Line 6, there's no negation to lose. In order to use implication, I would have to have a negation on the D to match this form, but I don't have that. However, anytime I need a negation, I can always get it by adding 2 negations and then just having one left over. So what I'm going to do is I'm going to go ahead and do double negation on the D. I'm going to leave C alone. Now I'll have a negation to lose when I go from disjunction to conditional, and I'll have a negation left over, which is what I actually want. So I do double negation on D from 6, double negation. Now I have something I can turn into a conditional. Implication says that if I've got a disjunction where the left piece is negated, I can turn it into a conditional as long as I drop a negation. Importantly, I'm only going to drop one negation because the difference between alpha over here and alpha over here is simply one negation. So when I do my implication, one negation drops off, but only one, so one remains, and my disjunction becomes a conditional. And I get this from 7 and implication. Good. Now we can check our conclusion, not D, horseshoe C, perfectly matches our conclusion up here, and our problem is finished. Our next rule is kind of an interesting rule. It's called exportation. And basically what it allows us to do is to take a conditional that has as its antecedent a conjunction and pull the left conjunct out to make it a main antecedent. So if I've got alpha and beta, horseshoe gamma, I can pull alpha outside the parentheses to get something like this. Alpha, horseshoe, beta, horseshoe, gamma. What I've done is I've taken the left antecedent, pulled it out, and what's left over becomes its own conditional in the consequence spot. Of course, this will work both ways. So if I've got a conditional where the consequent is also a conditional, what I can do is I can basically combine the two antecedents. So I can take those two antecedents, alpha and beta, pull them both out together to make them a conjunction as one antecedent. Okay, so let's work a problem that exploits this rule. Let's say I've got A, horseshoe parentheses B, horseshoe C, and I've got B, and I want to get as my conclusion A, horseshoe C. Now, when I look at this, what I realize is that I've got everything I need on line 1, and I've got an extra piece, this B. And so my goal is to get the B out of here and keep the A and the C. Now, B shows up as the antecedent in a conditional, and of course, if we want to get the consequent and lose the antecedent, we want to use modus ponens. But because modus ponens is a rule of inference or implication rather than equivalence, we won't be able to do modus ponens on line 1 and 2 because B is not the main antecedent. It's the antecedent of a conditional that's not the main connective. However, now that we have exportation, this is actually going to give us some freedom to manipulate the antecedents of problems. So in order to get B on the outside, I need to start working it to the left. So what I'm going to do is I'm going to move it from being associated with the consequent to being stuck with the antecedent back here using exportation. So I pull B out of these parentheses, bring it over here as part of the antecedent, which gives me A and B, horseshoe, C. And I get that from 1, exportation. Oh, forgot to mention. So we're going to abbreviate that EXP. There we go. There we go. There's a thumb. All right. Now that we've pulled it out, we can actually flip the order of these using our commutation rule, because in the parentheses here, we have a conjunction, and we know that with a conjunction, we can flip the order. So what I'm going to do is a commutation rule, and I'm going to move this B even closer to the left side, because my goal is to get it all the way over here. So I flip the conjuncts using commutation, gives me B and A, horseshoe C from 3, and commutation. Now B is all the way to the left. I still can't do modus ponens because it's inside the parentheses. However, exportation in the left to right version is actually going to allow me to capture this left conjunct and pull it back out of the parentheses. So when I use exportation on line 4, B moves out of the parentheses and A moves back over to be part of the consequent. So I get this from 4 and exportation. Now my problem is very straightforward. I've got a conditional. The consequent is what I want. The antecedent is something I already have on line 2. So a simple round of modus ponens will get me A horseshoe C from 5, 2, and modus ponens. Make sure you can see that. There we go. All right, we got 2 rules left. The next rule is called tautology. And this is one of the rules that you're going to forget you have, and I just speak from experience. Tautology is actually a very straightforward rule. It says if you have a sentence, alpha, then what you can do is you can replace that with the conjunction of alpha and alpha. This sounds weird, but it makes sense. If I say I have a piece of cherry pie, then it would also be true that I both have a piece of cherry pie and have a piece of cherry pie, because I'm just saying the same thing twice, and I already knew that I had the piece of cherry pie. So I can take alpha and turn it into a conjunction with itself. It comes in 2 flavors, like many of our rules. The other one says that if you have alpha, you can turn that into alpha disjoined with itself. So if I can go from alpha to alpha or alpha. Now, this version of the rule can be useful, but this is especially useful going in the other direction, because if I have the disjunction of something with itself, I can collapse that down using tautology to just get one of the disjuncts. So it's kind of an indirect way, or sort of a sneaky way of breaking down a disjunction. All right, so let's take a look at this rule using a problem. So let's say I've got something that looks like this. A horseshoe B or B. B and B. Horseshoe negation D. Therefore, negation parentheses D or D. Okay. Oh wait, we're missing a premise. We need one more premise. That's going to be A. Perfect. So when I look at this, I see that I want to get D by itself. And I know that these A's are going to work well together. I can take A on line 3 and plug it into line 1. But getting D out of line 2 is going to be a little bit tricky. And that's because modus ponens on line 1 is going to be B or B. But what I really need is B and B to do modus ponens on line 2. Definitely, though, I want to get D by itself, since D is the only thing in the conclusion. So let's go ahead and take a look at this and see if we can't get D by itself. So the first thing I'm going to do is the obvious thing, and that's just to use modus ponens on lines 1 and 3. When I do modus ponens on 1 and 3, of course I have the antecedent of line 1 repeated on 3, allows me to derive the consequent. So that gets me B or B from 1, 3 modus ponens. Now, I might be thinking, oh, I could do modus ponens on line 2 because I've got a B in the antecedent here. I've got B on line 4. Problem is this, for modus ponens, you need exactly the antecedent. And B conjoined with B is different from B disjoined with B because they have different main connective. The antecedent of line 2 does not match line 4. Fortunately, we have a brand new rule that's going to help with this. Tautology says if I have the disjunction of something with itself, so I have a disjunction with the same thing on both sides, I can collapse that disjunction down and get rid of the extra pieces. So I'm going to use the right to left version of the second flavor of tautology to get just B from line 4 and tautology. Now, this isn't exactly the antecedent of line 2 yet, but I'm getting closer. And at this point, I have a few options. One option would be use tautology again on line 2 to collapse this down so they match. Another option would be to use tautology on line 5 to extend it back out to a conjunction. Technically, I could even conjoin line 5 with itself to get the conjunction, but that's getting a little silly. So let's go ahead and use tautology on line 2 to collapse things down. When I do tautology on line 2, of course, I'm only doing it on the antecedent because that's where the matching piece shows up. I've got B conjoined with B, and the right to left version of the first flavor says that when you have a B conjoined with itself, you can collapse that down to get just B. So because this is no longer complex, I'm going to lose those parentheses. Everything outside the parentheses, though, will stay the same. And so I get this from 2 and tautology. Good. At this point, I've got a very straightforward modus ponens problem. I take B on line 5, plug it into line 6, and that'll get me negation D. And I get that from 6, 5, and modus ponens. All right, I'm almost there. I've got D by itself. I need D by itself up here, but again, conclusion doesn't quite look like this. Fortunately, again, I've got tautology that I can use. This time, what I'm gonna do is I'm gonna do tautology just on the D, and I'm gonna keep the negation as my main connective. So I'll keep the negation outside, expand inside the parentheses, and I'm only doing tautology on the letter D, not on this entire sentence. When I do that, I'm gonna replace D with the logically equivalent disjunction of D or D. Now, from 7 and tautology, I have my proof. Okay? All right, we've got one more rule, so let's take a look at that. The last rule is going to be a rule called equivalence. And we'll abbreviate that Equiv. Now, if you've been paying attention, you've noticed that we've got rules that cover all of our connectives except one. We haven't done anything with the biconditional. Equivalence is going to be our only rule for working with the biconditional. So right off the bat, anytime you see a biconditional, you know we're going to be using equivalence. Equivalence says this, and like many of our rules comes in 2 flavors, but equivalence says if you've got a biconditional, you can replace that with the conjunction of 2 conditionals. One going left to right, one going right to left. Biconditional A if and only if B just means if A then B and if B then A. Those are the 2 conditionals in the biconditional. So I can break that up into the conjunction of A horseshoe B and B horseshoe A. This version is nice because it gives us a conjunction. So you'll find more often than not this is the version you want. Simply because you get a conjunction, you can simplify. Likewise, if you have a biconditional in your conclusion that you want to make, getting the 2 directions of the conditional and conjoining them will allow you to create the biconditional. Okay, we get a second flavor of this, and the second flavor looks like this. A if and only if B is equivalent to A and B, or not A and not B. And this actually comes directly from our truth tables. So if you'll remember the truth table for a biconditional, A if and only if B,